Okay, hello everyone. Welcome to index laws. Now, index laws are rules that we can use to make calculations easier and to simplify expressions. So here's a quick example to show you why this might be helpful. So let's say we have a hot air balloon festival and we need to work out how much hot air in total we need for the festival. Now, let's say there were 6 times 10 to the power of 2 hot air balloons. First of all, just revision from last time. What does this mean? It means 6 times 10 times 10. I've got 2 tens multiplied together. And 2 times 10 to the power of 3, that means 2 times 10 times 10 times 10. Okay. So how much hot air do we need in total? Now you might have worked out that since we have this many hot air balloons and this much hot air for each one, you need to multiply these two numbers together. And that's correct. Now index laws are helpful because there's a particular index law which says that if I have 10 to the power of 2 times 10 to the power of 5, 10 to the power of 3, I just add up the 2 and the 3, and that makes 10 to the power of 5. So that will make this whole calculation a little bit easier. Instead of writing out everything here, you can just times the 6 and the 2, which is 12, and then times this one and this one, and that will be 10 to the power of 5. And then you can, because I've got 10 to the power of 5, that means if I'm timesing it by that, that means I'll have 5 zeros behind my 12. 1, 2, 3, 4, 5. And that's a little bit easier, I think, than working it out the other way. Okay, so I just told you an index law, but I didn't explain why you get, if I multiply this by this, I get 10 to the power of 5. And we are going to go through exactly why these index laws are true. So we're going to go through a table with all the index laws, and so we'll have the rule or the law over here. We'll have the example in index form over here, and the example in expanded form over here. Expanded form means if I have 2 to the power of 3, expanded form is what it really means. So that means 2 times by itself 3 times. Okay, so what I'd like you to do is actually copy down this table. And as we're going, so maybe pause it. As soon as we get to a new rule, just pause it and copy it down. And then I'll explain what's happening here. So first of all, we've got to accept that these rules have pronumerals. They're all pronumerals. There's no numbers in them. And the reason for that is because I can put any number at all, I can substitute any number at all instead of these pronumerals, and the rule will still work. So, for example, I'm substituting, instead of A, I'm substituting 2. So both of these A's now become a 2. Actually, sorry, all 3 of these A's become 2. And I've got M and N. Instead of M, I'm writing 3. And you'll notice that there's an M over here. Actually, no, sorry, that doesn't make sense. I'm substituting 3 instead of M. I'm substituting 4 instead of N. And over here, I've got M plus N, which is 7. In this case, because I've got 3 plus 4 equals 7. All right, that's what it means. Why is that the case? Well, if I look over here, if I've got 2 to the power of 3, that's 2 times 2 times 2. 2 to the power of 4, I've got 4 2's multiplied together. How many 2's do I have altogether? I have 7 2's. So that's equal to 2 to the power of 7. All right, so just make sure you've got that down and let's move on. Okay, now these rules do get more complicated as we go along, but if you concentrate on the explanations of why this is, you shouldn't find any problems with this. Okay, so now we've got the second rule, which is a to the power of m divided by a to the power of n is the same as a to the power of m minus n. Now I want you to see how helpful this is. Let's say I have 2 to the power of 27 divided by 2 to the power of 25. Instead of typing this in my calculator, I can just think about this rule and realize, okay, if I've got m, if I can work out what m minus n is, the answer will just be 2 to the power of that. So m would be 27, n would be 25, and the answer is just 2 to the power of 27 minus 25, which is 2. So this becomes a lot simpler. And so these index laws are really, really helpful for simplifying things. So we've got a simpler example here, 2 to the power of 5 divided by 2 to the power of 3. 5 minus 3 is 2, so I've got 2 to the power of 2. Now, why is that the case? If I write this out in expanded form, every time you write it down in expanded form, you should see that it makes sense. I've got 5 2s up here and 3 down here. And when I divide it, I can cancel out, all these 3 2s can cancel out with 2s on the top. So I can cancel out 3 of these 2s. I've only got 2 of them left. And that would be 2 times 2 is equal to 2 to the power of 2. So that's why it works. Okay, make sure you've got that down. We'll move on. Okay, this one is a to the power of m to the power of n. So this is when you're layering up powers. And this doesn't make sense necessarily until you look at some numbers. 7 to the power of 2, I take whatever that is and I raise it to the power of 3. Now again, it's really helpful to know what this actually looks like in practice. So 7 to the power of 2 is 7 times 7. Now if I'm taking whatever that is and taking that to the power of 3, that means I've got 3 of these, whatever this is, 3 of these multiplied together. So 1, 2, 3, here it is. And you can see that there's 3 lots of 2 here. And that's why we do 3 times 2, or m times n. And then we get 3 times 2 is 6, so we get 7 to the power of 6. Okay. Now this one is for if I have 2 numbers and they're multiplied together, and then there's a power outside the brackets. So an example of that is 2 times 5 to the power of 3. And that means I can actually, this is kind of similar to expanding the brackets, although it's not the same thing. I can say that's equal to 2 to the power of 3 times 5 to the power of 3. So if you look at an example of that, here is 2 times 5 to the power of 3. I've got 2 times 5 and there's 3 of them. And I'm multiplying them all together. But when you're just multiplying, you don't need these brackets here because everything is at the same order of operation. Everything is multiplying, so I don't need the brackets are only there when you've got different stages of the order of operations. So because I'm all always over here, I don't need the brackets, so I get rid of the brackets. And if they're all being multiplied, I can rearrange them however I like. So I've just rearranged them here. 2 times 2 times 2, because it's 3 2s, and 5 times 5 times 5. And what that is 2 to the power of 3 times 5 to the power of 3. So take as long as you like to pause this video and have a think about what's happening as you write them down. Okay, let's move on. All right, now this is very similar. It's just when I am dividing two numbers instead of multiplying them together inside a pair of brackets. So if I'm dividing 3 by 5, and I'm saying 3 divided by 5 to the power of 2, that's the same as 3 to the power of 2 divided by 5 to the power of 2. And if you want to see why this is the case, here's 3 fifths times 3 fifths. 3 divided by 5, same thing. And when you multiply fractions, you just multiply the top, multiply the bottom. So that's what we've done here. And 3 times 3 is 3 to the power of 2. 5 times 5 is 5 to the power of 2. Okay. The last one is an interesting one. It's just really, if you don't understand how this works, you can just look at this and think, and just remember what it means. A to the power of negative m, that's just the same as 1 divided by a to the power of m. This is very useful later on, but to see why this is the case, let's look at 8 to the power of negative 2, which we're saying is equal to 1 divided by 8 squared. Now, 8 to the power of negative 2, now we're using the previous index law. I wonder if you can see which one it is to work this out. So we're actually using this index law, and we're saying, because negative 2 is the same as 1 minus 3. Now, we're using this index law over here to remind you that 8 to the power of 1 minus 3, which is like this, is the same as 8 to the power of 1, which is just 8, and divided by 8 to the power of 3. Okay. And if I cancel out two of these 8s, I get 1 on the top and 8 times 8 on the bottom, which is 8 squared. Now, you don't need to know, you don't necessarily need to know why all of these index laws are true, but I think it helps a lot. And if you didn't understand all of these, make sure you at least understand the first one and perhaps the second one, as in why they happen, why it's the case. All right. We might do a couple of examples and then we'll wrap this up. Okay. So let's say we're asked to simplify. All right, 4a cubed b. Sorry, I'm saying a cubed, a to the power of 3. That's the same thing. Times 3a b to the power of 4. Now, how do we simplify this? Well, we need to look at all of the they're not like terms this time, but all of the bases. Because we can use some of these index laws, especially if the bases are the same. If you look at these first three index laws, these first two, these two relate to where you've got two bases that are the same and you're either multiplying them or dividing them. And in this case, I've got A and A, so we should really look at the first one when you're multiplying the bases. I mean, firstly, we have to do 4 times 3, just deal with the numbers, so that's 12. But here, let's use the first index law. A to the power of m times a to the power of n is a to the power of m plus n. So in this case, m would be 3, and n would be 1, because a is just the same as a to the power of 1. It's the same thing. Alright, so what that means is I have to add together m and n. So I have to add together 3 and 1. So I'll have a to the power of 4, 3 plus 1. Now here we've got b to the power of 1 times b to the power of 4. That's b to the power of 5. So once you learn how to use these and start to remember them, it becomes very simple to do some of these simplifications. Very easy to do some of these simplifications. Let's do a harder one. Okay, let's do a longer one. So and I'm just getting these straight from the textbook. These are some questions that the Cambridge textbook is going to ask you. The Victorian Cambridge Maths textbook. Now, this is mainly trickier because there's 2 stages. Alright. So for this one, let's just do the top and then we'll work out what to do based on the second index law. Eventually we'll get to the fraction. So on the top we've got 16 times 4, that's 64. A to the power of 8 times a to the power of 1. 8 plus 1 is 9. Oh, what am I doing? Sorry. Then I've got b to the power of 1, b to the power of 7. That is b to the power of 7 plus 1, which is 8. And on the bottom I've got 32 a to the power of 7 times b to the power of 6. Now, I need to remember that on my fraction, I've got m and n, a to the power of m divided by a to the power of n is a to the power of m minus n. So what's m and n? Firstly, let's just simplify this. Common factor of 64 and 32 is 32. So that's 2. If I divide 64 by 32, I get 2. A to the power of 9 and a to the power of 7. Well, m is 9. That's the one on the top, the index on the top. And n is the index on the bottom. That's 7. So what does it say? I have to do m9 minus 7, which is a to the power of 2. Then same situation, I have to do 8 minus 6. That's also to the power of 2. So the real benefit of this is I start with such a complex expression here, and I can make it a lot simpler. Alright, I may do a video on some of these examples using some of these harder laws later, but chances are they're going to come up in questions anyway. questions that are related to other topics. So I'll leave it there for now, and I'll see you next time.